Our title today is Visual Programming with NodeRed and FreeSwitch. This is something that I'm presenting really for fun. It's really interesting and fun to work with NodeRed and FreeSwitch. And this was actually discovered a little bit by accident when we were investigating something else. So let me present. My name is Flavio Goncalves. I have 21 years of experience in voice over IP since the first FXS and FXO interfaces and gateways. I'm a book and training author. Mono from the OpenSIPS project. So the context. So we were building. We have built our first cloud PBX in 2010 at SIPPOS, and we were building a new one. And one of the things that we wanted was to have a visual tool for the incoming calls for the dial plan. And then we started to study several options. And one of them was NodeRed. So what is visual programming? Visual programming was invented by John Paul Morrison in the 70s. It's a way to describe an application using nodes. Nodes are like black boxes. You can think of A as a, let's say, playback, or B as get digits, C, they are functions, right? And you can put your functions in a visual way. You can connect your functions in the system. And then by using information packets or messages, you pass messages from one node to the other. And it's very easy to program, very easy to see what you're doing, very easy to see the logic. It makes a lot of sense when you think about an IVR, when you think about inbound flows to our communication systems. So that's visual programming. And then we started to see alternatives in how to build a visual tool for our system. And we had two currents on our team, one that wanted to use NodeRed and the other one to develop our own interpreter. So let's talk about NodeRed, the first line. NodeRed is a programming tool for wiring together hardware devices. NodeRed is a visual tool with focus on IoT, on Internet of Things. It's open source. It has more than 500 modules, and it uses, well, just a second, an analog device here. It has more than 500 modules, and it uses Node.js, and you can install in a VirtualBox, Raspberry Pi, or the cloud. Here, actually, we are using it in a VirtualBox, right? So in my desktop, I have a VirtualBox. It's very easy to prototype things using NodeRed. So what are our objectives here with this presentation? Describe the options to integrate FreeSwitch and NodeRed. How can we integrate both tools? Differentiate between two types of integration, call control and external access. Understand the basics of Mode HTTP API. It's one of the modules that we are going to use to integrate, and Mode XML Rpc. Understand the basic. We can use also sockets if we want to integrate, and have some fun with demos. I have prepared 4 demos, but I believe we'll have time only for 2. So let's go. What problems are we trying to solve? Initially, what we wanted was to create a tool for the handling of inbound calls. But NodeRed is especially interesting when you want to integrate telephony with IoT, with Internet of Things. So the problem we are trying to solve is this integration. I have prepared 2 demos for you. One is the first one is very simple. We are going to get the FreeSwitch status, and based on the status of FreeSwitch, depending on the CPU, we are going to change a smart bulb from red to green and vice versa. And the second one, the second demo, we're going to use a smart plug to check if a pool is closed or not, based on if the filter is working or not. So these are 2 examples that will allow me to show you how to integrate FreeSwitch and NodeRed. So the first place, let me differentiate two types of integration. The first one is call control, and the second one is external access. Call control is when you start from the dial plan. So you're processing your dial plan, you're receiving a call, and then you transfer the control to NodeRed, right? On NodeRed, you can authenticate, you can route, you can answer, you can divert to a user, you can do whatever you want with a current call. Usually we are going to use outbound sockets or mode HTTP API to do this integration. So this is from dial plan to the NodeRed. And the second type of integration is from external access to NodeRed. So it starts from an external program. Let's suppose a switch. And then from the situation of a switch or a sensor, you can generate a call, can generate an SMS, and so on. The methods, usually we are going to use inbound sockets or mode XML RPC. And this is from NodeRed to dial plan. So there are these two types of integration, and we are going to show one demo using dial plan to NodeRed and another one NodeRed to the dial plan. Integration methods. There are actually two ways to integrate: the HTTP method and the and the sockets method. One is based on HTTP and the other one in sockets. Sockets is a little more powerful. You can do more things, and with sockets, you can actually develop your own modules for NodeRed. If you have enough time and skills to develop the modules using sockets, you'll be able to have a bidirectional communication. Using HTTP API, it's fun and nice, but it's very hard to get a simple flow. How can I say a flow that it's simple to understand and to build, because we are going to have, each time we interact, we have a new request, so we have to start from the beginning. So it's an interesting integration for simple things, but it's difficult to, as an example, to build a module based on the HTTP API. And XML RPC is perfect. If you want to send comments to FreeSwitch, if you want to start a call, if you want to send an SMS, it works quite well. It integrates very well with NodeRed. So these are the methods. I'm going to show you the ones based on HTTP. I have the other ones, the other based on sockets. I have created a small project on GitHub, so all the flows that I have created are there, along with the FreeSwitch configuration. So if you want to play, it's there. One thing I can tell you, it's a lot of fun. I would do just for fun, not even for. What's our lab? Our lab here is a virtual box, a FreeSwitch, and a NodeRed in this virtual box using Debian. Is on the address 192.168.15.163, and I have added a light bulb that costs less than 10 bucks, and a smart switch, also very, very inexpensive for a lab. So let's see how to use the HTTP methods. So the first one is the mode XML RPC. This one is for external access, so for an external entity to control FreeSwitch. So to configure XML RPC, you need to go to the xmlrpc.conf and enable the module, establish the port and the address, right? And also you can add a name, a password for the system, and all the API calls will be created on the IP address of the server, the port, and the web API. So there you can originate a call, you can send a message, you can get the status of FreeSwitch, and so on. To call XML RPC, you can use curl as this example. For NodeRed, we are going to use an HTTP request. It's a box. But what we are going to send is more or less the same thing, what is encoded like URL encode of an origination or whatever command FreeSwitch supports on its API, right? So you can actually generate a call. You can send an SMS using NodeRed. So demo, this is the demo number 1. To get the status of FreeSwitch and turn a lamp green or red. Let me bring here the NodeRed. Okay, so you've probably seen all of this. Seems weird, I know. So the first thing, all the boxes here are standard, except for the Tuya smart plug. All the other boxes are standard boxes from standard nodes from NodeRed. So the first node I'm using is an HTTP in. It creates kind of an HTTP endpoint for web services. So I'm creating a web service on the system. Oh, sorry. Let me go to the XML Rpc demo first. Sorry. And here I have a timestamp, another node. This node is also a standard. So we are simply injecting, it's here, injecting something on the script just to start. So on this timestamp, let me enable, it will inject the timestamp as a message each 5 seconds. So let me go done. Let me open the debug. Okay, we are in debug. So after the deploy, it will start. I have here a controller for the smart bulb. So let me enable. And then let me do a deploy. So now it's connected to my smart lamp. You're probably seeing a green lamp in the bottom of the screen, right? So, okay, so I can turn red or green, whatever I want. What's the idea? From each 5 seconds, this timestamp injects a timestamp on this function. This function, I just add headers. And then I have an HTTP request. This HTTP request to 127.0.0.1.80.80, calling the web API, the XML RPC, I'm calling a JSON command. In here, it's URL encoded, but I'm just calling the status of FreeSwitch. This is the equivalent of fs CLI-X status. Obviously, if you want to see this encoded version, I could use, say, decode URL, just to see what we are doing here. If we decode here, it's just a common status, and the data is free. So it's very simple, nothing complicated. Not too much complicated. Great. So we are doing an HTTP request to FreeSwitch. And depending on the response, we are going to parse the response. And I can see here on the debug the response. So I have the status. And in the status, I have this CPU allowed parsed on as a JSON, right? So I have 99.6% idle, this machine. So everything is green. And here I have a switch. And switch says, if this idle CPU allowed is below 50, it will send to the first exit. If it's above 50, to the second exit. And then we have this red if idle below 50 and green if idle above 50, right? These are debug nodes, right? And these are some injection nodes that I can use to control the smart bulb. Okay, let's put some load on FreeSwitch. Let's stress a little bit the CPU. And stressing the CPU, I'll start to see in the comment here The idle here will start to decrease, right? Idle CPU, 74, and it's decreasing, and now the lamp is red. You're probably seeing in the screen on left or right the red lamp. If you can see, I can put here in. Let's see. I have just a lamp with this smart bulb. So this is a way to integrate NodeRed with FreeSwitch. Great. So let me turn off. And just to avoid any problems, let me disable. And let me disable the smart bulb here too. Great. So this is the demo of the XML RPC, right? So we are controlling smart bulb depending on the status of our FreeSwitch server. Great. So let's move next. Let me share again my presentation, change the configuration, and that's it. So the demo number one is complete, and it worked. It's something rare. Demos working on presentation. Oh, using mode HTTPI to control a call. There's a module on OpenShips called the HTTP API. It's used to control a call. So we have in the FreeSwitch dial plan a line here saying whenever I have a call to *99, send the control to an external entity using the module HTTP API. And this module will wait for documents such as the one below. So XML, FreeSwitch, HTTP API, and then you have the work you want to do. So you can send a playback. In this case, I'm sending a playback, but you can control the call. You can authorize a call. You can hang up. You can complete a call. You can transfer to different places. There are many things you can do to control a call. It's the case of an IVR. And it's interesting that in the case of IVR, you can send a request to a different URL, and it's a good way to control a call based on NodeRed. So the demo number 2 that I'm going to show using this mode HTTPI, and is the pool open? So I'm going to check smart plug to see if the filter is working or not. And okay, so let's see. Let's move to the next demo. And HTTPI demo. Okay, so we have our Wi-Fi plug. It's here, connected. The FreeSwitch here, it's connected. Everything is okay. So let's start here. We have this HTTP in. So it creates an HTTP endpoint on the system. So whenever I dial *99, it will start on NodeRed here on FreeSwitch start/fs. I'm doing this presentation only with the simplest things possible. You can create your own nodes if you want to simplify a little bit more. This here, request and response and send, they are actually debug nodes where I can see this message. So I can see after HTTP request and some other data from our script. Actually, we are having some data here because the smart plug generates a request from time to time. So that's why we're seeing things on the debug. So starting with the FreeSwitch, I'm using a function just to save the request and response. I had to do this because this Wi-Fi plug does not pass the complete message ahead. It truncates only the payload, and it's a small problem on the Tuya smart plug. Something that I could have fixed on the source code, but I didn't have a lot of time. So In this save request also, I'm setting the message payload, so the message to be sent to the next node, to request. If I grab here the Wi-Fi plug, there's a great documentation here. If they receive in the payload a request, it will send me the state of the device, including all the properties. So if the message here is request, the Wi-Fi plug will return to me the status of the Wi-Fi plug, if it's turned on or turned off. Again, in switch, also one of the standard nodes, I will check the content of the payload and the data point 1, if it's true or false. This will define to me if the smart plug is connected or not connected, right? And based on the status of the smart plug, we are going to send a message saying, okay, pool closed, so we are in maintenance, or free, the pool is open, so I'm sending the document exactly how HTTP API, the way HTTP API works. And then I have another box. I will recover the response and request, part of the message that I have lost on this node. And then I will send to the FreeSwitch, back to the FreeSwitch. I will send a 200 OK with the content. So this is the example of mode HTTP API. So let's do it. I have a microSIP connected, and I will call the *99. Let's see. Probably my audio will go up a little bit. Sometimes this happens because of the microSIP. Then I will adjust back.
The pool is...
So the pool is open, right? So it's the first, depending on what I have received on the status. If I look at the status, the response object, oh, sorry. I'm still seeing some things here. Let me deploy, sorry. Let me change the plug. And then I will call the *99 again.
The pool is closed.
Now the pool is closed because I have changed the status of the sensor. If I look at the message coming from the Wi-Fi plug, so after Wi-Fi plug, I look at the data here, and I have in the payload object this data point, 1 is true. And when I change the switch, I actually change this DPS 1 to false. Here I have other data points. I can actually have the voltage or the consumption of energy on the smart plug too. So when I do status, I get the status of several data points. So depending on the data point, you have to go to the documentation, see exactly how this number translates to what you want to see. So this is an example on how to handle a call depending on the status of a sensor or on the status of a plug. Great. Let's go next. Let's see how I'm on time. Everything seems okay. Let me go back. It's very hard when you don't have the feedback of the audience going from long distance. How to connect using sockets. And okay, there's something wrong with it. We can also connect using sockets. So for sockets, we have inbound sockets and outbound sockets. So for inbound sockets, I have to create the event socket and prepare for the port 8021. And for outbound sockets, I can use call control based on outbound sockets. So it's not very hard to do too. And I will not go to the demo because I know I don't have enough time for it. So this is the socket out demo, and this is the socket in demo. So we connect to the port TCP 1881, and depending on the status, we can connect, playback, and so on. All of these demos are on the GitHub. If you look at my GitHub, Flavio Goncalves, ClueCon 2021, all the flows are here and the configuration of FreeSwitch if you want to try. Back to presentation just to finish what we started. I hope my audio is okay. So, despite of being really fun to use the NodeRed, there are some cons on NodeRed. It still requires some knowledge in JavaScript, so it's not exactly simple. It still requires the understanding of FreeSwitch APIs, but it can be simplified using modules. You're going to see tomorrow, there's a presentation from Dave Orton about Jambones. In Jambones, Dave has created these modules for Draft.io to where you can do it easier than what I'm showing you here. But this presentation, I try to use just standard modules and FreeSwitch. But if you can build your own modules, it can become simpler. However, we needed a little more, let's say, customization on the interface, and we needed to make it simpler for the user. Then we decided to build our own editor and interpreter. This is what we are looking for. Maybe next year, we're going to talk about how to build the editor, JSON description language, and how to create an interpreter to run your own visual programming. For the reading, we have this GitHub where you can get the demos. We have the Jambones from Dave Orton. It's there. It's much easier to use, but it's not based on FreeSwitch. Actually, Draft.io uses FreeSwitch as a media server, but it's a little bit different. Draft.io is based on JavaScript, so it's a very good fit for NodeRed. There are some flows also in Twilio and Nexmo. There are other companies using the integration with NodeRed. Conclusion: the integration of NodeRed is very useful, but not necessarily simple. You can have telephony and IoT in the same place, but still not very intuitive for IVRs, at least for now, at least not without creating your own modules, your own boxes. So I think, let me stop sharing, and now we can talk.
That's great, Flavio. Thank you very, very much. Before we have any questions, we'll have a quick round of applause for Flavio. Thank you.
Oh, thank you. I hope my audio is okay.
Yeah, as usual with Flavio, highly practical training, with real life stuff. It's really excellent. Does anybody in the room have any questions for Flavio on NodeRed, the FreeSwitch modules he used, or the visual programming aspect in general? Where was that? Yes, sir. David, if you want to go to that mic, you might have to press the button for a short time to switch it on.
Yep, it's working.
Yeah,
so
here's David.
Is anyone using NodeRed for people to use it to set up, not so much to the back and forth where you're getting feedback?
Sorry?
Not so much as using it to get feedback and to constantly be working, but is any way of using it to just give end users a way of quickly setting up an IVR and then exporting that to some kind of configuration and pushing it to FreeSwitch? So not like it's constantly up and interactive, but people can drag and drop, create IVRs, create whatever they want, object from the list of functions or whatever you want to call them. You tell it what to do, and it'll let you drag and drop and create an IVR or create a phone system that way, and that'll translate into dial plan.
Yes, you can do it, right? You're going to see tomorrow Jambones. Jambones has done a very nice work in this area. But to make it simpler, you need to create your own nodes. And to create your own nodes, you need a bidirectional protocol like WebSocket or sockets. And when you use HTTP API, it has the web server paradigm. So you send an HTTP request and it returns. When you use an IVR, it sends to another URL to continue the flow. To have what you want to create the IVR interface on NodeRed, you need to create your own modules. And on this module, you send the playback receive the response, and go to the next module. So it needs to be bidirectional. Before doing the presentation with sockets, I was trying to figure out how to do it with the.
Oh, we got a frozen Flavio, which is unusual because from Brazil you wouldn't usually freeze, would you?
Not here, not with 30 degrees. Do you see me now?
Yeah, we've got you, Flavio.
Okay. Sometimes I was seeing the internet on the hotel. Sometimes it was freezing on few presentations before. But what I was saying is to build the IVR is not very simple. What we did was to create our own editor, use the node, use the JSON file, and create an interpreter to interpret the IVR on the system. It's much easier, and we don't need to teach the user JavaScript.
Great, thank you, Flavio. David, did that answer your question? You're a happy man. Okay, I don't think there's any questions online, but I noticed that Sebastian Rojo did put up Flavio's GitHub there, github.com. Flavio Goncalves /ClueCon 2021. So the official repository is there. Okay, Flavio, I don't see any more questions in the room. Oh, I do. Okay, there's a question. If you'd like to, you might have to switch the mic on, sir. Yeah, you're on. Here's another question, Flavio.
Flavio, was there ever a consideration to interface with FreeSwitch via Lua or Mod V8 JavaScript?
Yes. Actually, what we did, the first thing we did was to use Lua to create an interpreter, right? But not to integrate directly with NodeRed. But we have used Lua in our first version for the interpreter, because what we need on NodeRed is a direct connection, direct HTTP connection or socket connection. So Lua in this case I think it wouldn't apply.
Okay, thank you very, very much, Flavio. I'll go one more scan, and I don't see any questions. So let's give a very big ClueCon round of applause for Flavio Goncalves.
Thank you, Dave.